Some scientists think the building blocks of life on Earth might have come from outer space. No fluff, no fiction, just the mind-bending possibility that we might essentially be aliens on what we now call our home planet. Is organic life a homegrown phenomenon, or did we ultimately come from beyond the stars? Today we explore the idea that we might actually be the aliens, and to do this, we start in the cosmos and dive towards Earth and into the deepest recesses of our oceans. The concept known as panspermia suggests that life exists throughout the universe and is spread by space dust, meteoroids, asteroids, and other cosmic objects. Essentially, life can occur anywhere where the conditions are favorable. Historically, panspermia has received little support amongst mainstream scientists. Many feel this hypothesis doesn't really answer the question on the origins of life, but merely shifts its origins to another time and place in the cosmos. It is also difficult to prove experimentally. However, more recent analysis of celestial objects and asteroids have started to support the idea of life coming from beyond the stars and give more color to the theory, which we will look into later in this video. We start this journey in deep space during the late heavy bombardment, Earth's meteor shower era. Giant rocks zooming through space and crashing into Earth as well as Mercury, Mars, and Venus, like cosmic bowling balls. This period, known as the late heavy bombardment, occurred around 3.8 to 4.1 billion years ago, when we think Earth and the inner solar system faced a huge increase in asteroid bombardment. The exact cause of the late heavy bombardment remains a topic of debate. One leading theory, the NICE model, suggests that the giant planets in our solar system underwent a period of orbital rearrangement, which destabilized a portion of the asteroid belt and/or the Kuiper belt, sending a barrage of objects into the inner solar system. But space rocks weren't empty-handed. They came bearing gifts like water and complex molecules like amino acids. So we know space was a hostile region and was frequently throwing cosmic stuff towards Earth. What was Earth like at this point? No surprise here, the planet was also a hostile environment back then. Earth in its infancy, nearly 4 billion years ago, was a wild, untamed place, with landscapes dramatically different from what we see today. Volcanoes erupted left and right, spewing lava and a toxic cocktail of gases into the air. The atmosphere was thick with nitrogen and carbon dioxide, but don't expect to take a deep breath. Oxygen was not yet present in the atmosphere. UV radiation would also be reaching Earth's largely molten surface. Over time, as the planet started to cool down, the early signs of an atmosphere would have started to appear containing mainly methane, carbon dioxide, and ammonia. Yes, this would have been an eye-watering stench. With the overall cooling of the planet, water vapor condensed, leading to regular rainfall, which led to the creation of the early oceans. These primitive oceans were preparing to become the cradle of the very first forms of organic life. The final phase of this journey into the origin of life takes us into the primitive ocean. The ocean is an intriguing environment. Much of it remains unexplored even today. However, all those billions of years ago, they played a pivotal role in the formation of early life forms. Inside the oceans, we have hydrothermal vents, which are fissures on the seabed. They are usually found near areas of volcanic activity. Cold ocean water seeps into these fissures, gets heated by magma deep in the seabed, and is released back into the ocean. When this superheated mineral-rich water meets the cold seawater, it triggers the precipitation of minerals, leading to the formation of chimney-like structures known as black smokers or white smokers, depending on the types of minerals being emitted. Water in these vents have a rich chemistry. Temperatures can reach 400 degrees Celsius, and the fluid contains an abundance of dissolved minerals like iron, copper, and zinc. It is this active chemical-laden environment that provides an energy source for microorganisms. One such cell formation would be lipid-like molecules, which could have formed the precursors to cells known as protocells. Protocells would have provided a safe contained environment where biochemistry could take place. This is the basic premise of the RNA world model. This leading hypothesis outlines the idea that RNA molecules, which can both store genetic information and catalyze chemical reactions, were among the first self-replicating molecules. In the protective environment of a protocell, these RNA molecules could replicate and evolve. As these processes were underway, these primitive organisms would have undergone natural selection, where beneficial chemical pathways would become more common, leading to more complex molecules and the very first true living organisms. The transition from this simple chemistry to actual biology, organisms with a consistent mechanism for inheritance and metabolism, is a critical step and one of the most intriguing mysteries in the study of the origins of life. Cosmic objects plus ocean vents equals to microorganisms. Meet your great, you get the picture, grandparent, LUCA. You know that saying, we're all connected? Well, it turns out it's scientifically true. LUCA, or last universal common ancestor, is like the ultimate grandparent of all life. The cool part? Genetic evidence hints that LUCA loved hot, oxygen-free places. So, it's quite likely that this ancient being called hydrothermal vents home. We have also found traces of organic molecules in extraterrestrial environments such as meteorites, comets, and in interstellar clouds. These compounds include amino acids, nucleobases, sugars, phosphates, lipids, and water. Combinations of these compounds would have allowed cellular organisms to form as they contribute to the creation of proteins, DNA, and RNA, cellular structures such as membranes, and cellular processes such as energy conversion. Think about it. If the essential building blocks for life can travel through space, it means they might not be exclusive to Earth. Amino acids and other life starters could be as common in the universe as stars and galaxies. This is no small revelation. It means life could be not just an earthly phenomenon, but a cosmic one, reshaping our understanding of life's possibilities beyond our planet. The balance of life, from adversity to opportunity. This all paints a picture of delicate balance. Earth had its rough patches, sure, but it also had secret safe havens like the deep ocean vents. Meanwhile, the cosmos, with its unimaginable vastness, acted like a caring neighbor, tossing some sugar over the fence when Earth needed it. It's as if the universe itself conspired to make life possible against all odds. The cosmic and terrestrial ballet. Life isn't just an Earth-only affair. Cosmic gifts like asteroids brought essential elements that stirred the primordial pot. Earth provided the stage, and the universe supplied the props. Together, they performed a ballet so intricate that it gave rise to you, me, and every living thing we know. Life's grand scale. From molecules to the cosmos. To truly grasp the miracle of life, we've got to zoom in and out. One moment, we're looking at molecules meeting for the first time in the depths of the ocean. The next, we're contemplating how celestial events, like exploding stars, sprinkled key elements onto Earth. Wonder in every drop, awe in every thought. When you think about it, it's all pretty mind-blowing. The early Earth, as rough as it was, had secret pockets where life could kick off its shoes and relax. And the universe, so mind-numbingly vast, sent just the right ingredients our way. The wonder of it all, a cosmic connection. The dance between Earth's unique corner and the universe's boundless generosity should stir up a sense of wonder. The vast scale, the intricate details. It's like an epic movie with a cast of billions, spanning from microscopic molecules to the far reaches of the cosmos. Therefore, let us be in amazement of this cosmic symphony, which has bestowed upon us the greatest gift of all, life itself. Final thoughts. The perfect marriage, Earth meets cosmos. In the final act of our story, let's take a moment to marvel at how Earth's unique makeup and gifts from space came together in a perfect union. It's like Earth rolled out the welcome mat for cosmic deliveries, water, minerals, and even complex molecules that made life possible. The balance, tough times and safe havens. Sure, Earth wasn't a paradise from day one. It was a world of fire, storms, and barren landscapes. But even in this harsh reality, life found cozy corners, like deep-sea vents, to call home. It's as if the universe knew where to send its life-making packages, turning struggle into opportunity. Big and small, the wonders of scale. This story doesn't just stick to one size. We zoom in to see atoms and molecules, the building blocks of life, interacting in the ocean's depths. Then we zoom out to witness cosmic fireworks, asteroids and comets, that made Earth the thriving world it is today. It's like looking at life through both a microscope and a telescope. How incredible is it to be part of this grand story, full of twists and turns, that led to us? Let that sink in as we close this chapter. And don't forget to like the video and subscribe to our channel. See you in the next video.